Hi friends, welcome to the lecture of Advanced Discrete Mathematics. Today we are going to study what should be the fusion of two vertices in a graph G. Let fusion of two vertices. Fusion. Let U and V be. Let U and V be distinct vertices of a graph G. Distinct vertices of a graph G. We can construct a new graph G1. We can construct a new graph G1 by fusing these two vertices. Fusing the two vertices. Namely, by by replacing them by a single new vertex by a single new vertex x such that every edge incident with either u or v is now incident with vertex x with yes. So, what is the fusion of two vertices? If suppose U and V be two distinct vertices of a graph G, now we have to construct one new graph G1, which is obtained by fusing the two vertices U and V, and which is nothing but we have to fuse these two vertices. That is by replacing them by a single new vertex X, such that every edge that was incident on either a vertex U or a vertex V, then every edge that was incident on either U or V is now incident on a vertex yes, that is end U and end V becomes the end yes, that is the edges whose ends are either U or V, those edges which has ends U and V is now becomes the end yes. Now take one example. Suppose this one is the graph G. 1, 2, 3 and 4. V1, V2, V3, this one is the graph G. Now we have to fuse any two vertices from a graph G. Let us fuse vertex V3 and V4. That is, we have to replace these two vertices by a single vertex. Then we get after fusion. If suppose this one is the vertex V3 and which is V4, that is the fusion of these two vertices V3 and V4. Now here is vertex V2 and this one is vertex V1. Now there is an edge joining between vertex V2 to V3. So this one is the edge joining between vertex V2 to V3. And there is a edge joining between vertex V3 to V4. So this one is the V3 equal to V4 and which is nothing but our X. And there is a edge joining between vertex V3 to V4, which is nothing but the loop at the vertex V3 to V4. So this one is the fusion of the vertices V3 and V4. Let us see another example. Second example, suppose this one is the graph G. Now we have to choose vertices U and V. That is, we have to replace these two vertices by a single vertex X, and those edges which are incident on one vertices U and V. Now we have to incident on a vertex X. So after fusion, the graph is, if suppose this one is the vertex U equal to V, that is the vertex X. Now this one is the vertex A, this one is the vertex B. See, there is an edge joining between vertices U and A and vertices B and B, and U equal to B. So there is an edge joining between vertex X to A and X to B. As there is an edge joining between vertices U and V, then here is one loop. Now this one is the vertex C and this is the vertex D. So there is an edge joining between A to C. Now again there is an edge joining between vertex B to C. So here we get a parallel edge. Edge joining between vertex C to D and V to D. This one is E1, E2, E3, E4, E5, E6, E7. From this, we can conclude that this one is the graph G1. The graph G1 has, which implies the graph G1 has one less vertex than one graph G. Since in graph G1 we have fused two vertices U and V and replaced them by a single vertex X. So graph G1 has a one less vertex than a graph G. Here there are 7 vertices, 1, 2, 3, 4. Sorry, here there are 6 vertices, 1, 2, 3, 4, 5 and 6. And here there are only 5 vertices. So graph G1 has a one less vertex than the graph G. And degree of vertex X is just the sum of degrees of U and the degree of vertex U is nothing but the degree of vertex X is nothing but the sum of the degrees of the vertices U and V respectively. That is, here the degree of vertex U in a graph G is degree of vertex U in graph G is 3 and degree of vertex V in a graph G is 4. So now we have to find out the degree of a vertex X. According to this statement, degree of a vertex X is nothing but degree of U plus degree of vertex V, which is 3 plus 4 will be equal to 7. Let us check whether the degree of a vertex X is 7 or not in a graph G1. So degree of vertex X equal to 1, 2, 3, 4, 5, 6, 7. Since loop of a vertex contributes 2 degree, one at each vertex, therefore the total degree of a graph X, total degree of a vertex X is the 7. Since 1, 2, 3, 4, 5, and this one loop contributes 2 degree. So 5 plus 2 will be equal to 7. The degree of X is 7. Therefore this one is true. Now when the fusion process when the fusion process is applied to fusion process is applied to adjacent vertices U and V does not alter, that it changes or not changes the number of connected components. Connected components. That is the component containing U, vertex U in G now gets changed to component containing the fused vertex X, fused vertex X, and all the remaining and all the remaining components of a graph G unaltered, that is not changed. So, when fusion process is applied on two adjacent vertices, then it does not changes the number of connected components of a graph G. That is, the component containing U in a graph G is now a component containing X in a graph G1, and all the remaining components of a graph G remains unaltered. That is, if suppose there is one graph G having three connected components. Suppose and B5, B6 and B7, and here is B and B9. This one is the graph G. And here we have fused two vertices V3 and V4. Then after fusion the graph G becomes the graph G1, and which is nothing but here is vertex V1, V2, V3, and there is a loop at a vertex V3, and which is nothing but V4, and this one is the remains unaltered V5, V6, V7, and V8 and V9. That is, when the fusion process is applied on two adjacent vertices, V3 and V4 are two adjacent vertices, then the number of connected components of a graph GR remains not changed. That is, here there are three connected components in a graph G, and G1 contains also three connected components. Okay, now if vertex Vi is fused to its neighbor, that is adjacent vertex, its neighbor means two vertices are said to be neighbor of each other if these two vertices are adjacent, that is there is an edge joining between these two vertices. Now if Vi is closer to its neighbor Vj to form a new vertex W, then since each edge since each edge of the form Vi to Vk is or of the form Vj to Vk is now gets changed to one of the form W to Vk, that is after fusion of two vertices Vi and Vj. The edge of the form Vi to Vk or edge of the form Vj to Vk is now get changed to one of the form W to Vk. Then the adjacency matrix then it follows that the adjacency matrix of the new graph G1, it follows that the entries in the adjacency matrix of the new graph G1 follows that the new graph G1, the entries in row and column corresponding to vertex W corresponding to vertex W is obtained by taking the sum of corresponding entries given by vertices Vi and Vj in its adjacency matrix. That is, if vertex Vi and Vj are two adjacent vertices, then each edge of the form of vertex Vi to Vk or Vj to Vk is now gets changed to the form W to Vk. Now we have to find out the adjacency matrix of this new graph G1. Then the entry corresponding to this vertex W are obtained by just taking the sum of vertices Vi and Vj in its corresponding adjacency matrix. Before that, let us see, before the example of this statement, let us take one method, shortcut method to find out the adjacency matrix of a new graph G1 from a graph G. That is the adjacency matrix fusion of two adjacent vertices. This one is the shortcut method to find out the adjacency matrix of the new graph. In first step, change use row, change use row to the sum of use row with this row and symmetrically change use column, change column the sum of use column with this column. Column. And in second step, delete all the rows, delete all row and column corresponding to vertex B. Vertex B. The resulting matrix is the resulting matrix the adjacency matrix of the new graph G1. The new graph G1. So, if we have given a graph G, then we have to fuse any two vertices U and V from a graph G. Then we have obtained a new graph G1. And now we have to find out the adjacency matrix of the new graph G1. Then we have to change use row to the sum of use row with which row, and symmetrically we have to change use column to the which column. And in next step we have to delete the row and column corresponding to vertex V, and the resulting matrix is nothing but the adjacency matrix of the new graph G1. Take one example. Suppose this one is the graph G, and after fusion G1 is nothing but and this one is the graph G1, which is obtained by fusing the vertices U and V. Now we have to find out the adjacency matrix of a graph G1 by using the adjacency matrix of a graph G. That is, suppose first find out the adjacency matrix of a graph G. In adjacency matrix, the rows and column are represented by vertices. So here there are 6 vertices. Now find out the 6 cross 6 matrix. Now there is a no loop at vertex A, then the corresponding entry will be 0. There is an edge joining between vertices A and U, so the corresponding entry will be 0, and all the remaining entries are 0 since there is no edge joining between the A to all the other vertices other than U. Now U to A 1, U to U 0, U to B, U to B 1, U to C 1, U to B 0, B to A 0, B to U 0, B to B 0, B to B 1, 0, 0. B to A 0, V to U 1, V to B 1, V to B 0, V to C 1, V to B 1. Now C to A 0, C to U 1, C to B 0, C to B 1, C to C 0 and C to B 1. Now D to C is 1 and D to B is 1. B1, B to C1 and this one B to 0. So this one is the adjacency matrix corresponding to graph G. So now we have to find out the adjacency matrix of a new graph G1. So according to that method, we have to replace use row to the sum of use row with use row and change use column to the sum of use column with which column. First we have to replace change use rows to the sum of use row to the which row and change use column to the sum of use column with which column. So change. First replace use row to the sum of use row plus with row. 1 plus 0, 1, 0 plus 1, 1, 0 plus 1 again 1. We have to delete this corresponding. We have in second step we have to delete this rows and columns. First let us find out 0 1 0 1 0 0 0 0. Now change use row to the sum of use row with 0. 1 plus 0 1, 0 plus 1 1, 0 plus 1 is again 1, 1 plus 0 1, 1 plus 1 2 and 1 and all will 0 0 0 1 0 0. And we have changed use column to the sum of use column with which column. 1 plus 0 1, 0 plus 1 1, 0 plus 1 is again 1, 1 plus 0 1, 1 plus 1 2 and 0 plus 1 1. Yes. 0 1 1 0 1 1 0 1 1 0 0 1 0 0 1 0 0 1 1 0 1 1. So here we have changed use column use row to the sum of use row with which row and use column to the sum of use column with which column. According to second step, we have to remove the word column A, B, C, D, E, in second step, we have to remove the vertex U and so we have to remove the row and column corresponding to vertex V. That is, we have to remove this one column and this row. So after removing these rows and columns, we get the new graph, new adjacency matrix. Which is nothing but here is A and U is nothing but after addition of these two rows and column, this is nothing but vertex U. A, X, B, C, D, A, X, B, C, D. 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 1, 2, 1, 1, 1, 1, 2, 1, 0, 1, 0, 0, 2, 0, 0, 1, 0, 1, 0, 1. So this one is the adjacency matrix of a new graph G1 according to this method. According to this method, let us check whether this method is correct or not. Find out adjacency matrix from this graph. A, yes, B, C, D. A, yes, B, C, D. Now, there is no loop at vertex A. There is an edge joining between A to X. Now X. Loop X to A1. There is a loop at vertex for X. Okay. B1. X to C2. And X to B1. Now, B2 UN. B2 H0. B2 X1. B2 H0. And C2A0, C2X2, C2B0, C2C0, C2B1, D2A0, D2X1, D2B0, D2C1, D2B0. This one is the adjacency matrix from this graph, and this one is from this method. Let us check whether the entries of both the matrices are same or not. 0, 1, 0, 0, 0, 1, 1, 1, 2, 1, 0, 1, 0, 0, 0, 0, 2, 0, 1, 0, 1, 0, 1, 0. So both the matrices are equal. So this method is true. Okay. Thank you for watching the lecture.